Hey students, welcome to Psych History 3 Lab, Module 6, where we'll be talking about repeated measures and mixed designs. So to start off, I just want to define two key terms here. The first is repeated measures, and essentially repeated measures are when subjects participate in all conditions of an experiment or provide data at multiple time points. So as you can see from our figure here, we have a population, then we get a sample, and then we have the same group of participants participating in all group time points of the study. Additionally, another term I want to define for you is sphericity, which we're going to be discussing quite often in this subject today when we're running our analyses. But essentially, I want to just say sphericity is the quality of variances of the differences between treatment levels. And essentially what that means is that we take the differences between our treatment levels, so our baseline, post-test, and maintenance in here, and the differences are supposed to be evenly distributed. However, that's not always the case. So in today's lessons, we're going to be checking that sphericity assumption and saying if we don't have sphericity, then we have to go through a different set of statistics to understand what the true parameter values are. Whereas if we don't violate that sphericity, we go through the normal nuances in determining things. And you'll see what that's like later. But I just wanted to define that term for you. So what we're working with today is we're working with within subjects designs and mixed designs. And essentially up until now, we've always been doing between subjects designs in which we have just participants and they only have one time point. Now we're going to be working with within subjects designs in which there's participants that all run through the same exact treatment conditions at different time points. And then we'll also be discussing mixed designs in which we say they all go through the same time points but are given different treatments, either treatment or control. And that's what we'll be working with today. So before we were working with between subject designs, today we're going to be working with within subject and mixed designs. So for our data set today, what it is a researcher is interested in the length of time it takes to say 2-syllable, 3-syllable, and 4-syllable words. She first times how long it takes each participant to say the 2-syllable word, then the 3-syllable word, and then the 4-syllable word. However, half of the participants are put in a condition in which there's a distracting noise in the background. So she's interested to see if there's a difference between the control condition and the noise condition. So let's go ahead and parse this all out. So to start off, we have this noise condition. That's our between subjects factor, in which every participant is only exposed to one condition, either control or the noisy condition. Next is number of syllables, which is known as a within subjects factor, in which every participant reads the words of all 3-syllable lengths. So every participant is reading either 2 syllables, 3 syllables, or 4 syllables. They all read those. And our between subjects is the noisy condition and the quiet condition. And then our outcome variable is the length of time it takes to say each word. So, like I said, noisy and quiet are our between subjects conditions. The number of syllables read is our within subjects factors. So let's go ahead and get started in R. So I'm going to go and open up RStudio. I'm going to go ahead and create a new project, new directory, new project. Name this module _06. Create that project. I'm going to go and zoom in for everybody too. And then we're going to go and download the data set. So to get to the data set, you just go to home or modules. Oh, that's not where I want to be. You go to home or modules, go to module 6 lab, and download the syllables.csv. Okay, the file, save as, browse it to that project folder. There we go. Exit out. Confirm that it did save in our directory. Let's go ahead and open up a new R notebook. I'm going to bring this down a little bit. There we go. Let's bring it smaller. There we go. Okay, and we'll name this repeated measures. And we'll go ahead and create a new notebook. TOC:yes. We'll save this. Save it module 6 notebook. Okay, so let's see what we got next on our slideshow. So next thing we're going to do is we're going to go ahead and, first of all, I'm going to load up some notes here if you don't mind. There we go. First thing we're going to do is we're going to be installing a new package, the EZ package. We're going to be using this to run repeated measures ANOVAs, and then we'll use our classic tidyverse package and psych package as well. So Let's go ahead and do hashtag load libraries. Go ahead and insert a new R chunk and do install dot packages, and the package is going to be ez in lowercase, and we're going to do library tidyverse library ez library psych, and we should run that all and it should run successfully. We're going to install a package, so it's going to take a little bit of time. Give it some time just to load up. There we go. Load in the tidyverse package and the ez package and then the psych package. Okay, perfect. So I'll go ahead and hashtag that out. I'm just going to rerun this so we get some more room in here. Okay, so let's see what we got next in our slideshow. So we downloaded our packages, and then we're going to go ahead and read in our syllables .csv. So ID is subject ID, length equals the number of syllables in the word, so either 2, 3, or 4. Condition is either whether than the control condition or the noisy condition, and time is the outcome variable, which is milliseconds it took to say the word. So let's go ahead and just do hashtag import data. We're going to create a new R chunk, and we're going to name this SYL, use an assignment operator, use read underscore CSV, and then quotation marks, it'll be syllables dot CSV. Go ahead and read that in. There we go. And just to confirm it all in, so we have ID, length, condition, and time. Okay, let's see what we got next. Oops, so let's go ahead and describe the data set. Describe the data set. Insert a new R chunk. Describe SYL. There we go. So we have 48 observations. Our mean outcome is 519.67. So, and we got, looks like our groups are split up evenly, 0.50. Length of time, the median is the mean is 3. Okay, and yeah, so 519.67 milliseconds on average to say each word. So let's see what we got next. So the next thing we're going to do is we're going to go ahead and factor all of our variables. And as you can see, we're even going to be factoring the ID variable because that's going to come into play a little bit later. So let's go ahead and do our factoring. So we'll do hashtag factor our variables, insert a new R chunk. So we're going to do SYL. We're going to rewrite over our syllables. We're going to do mutate SYL, comma. We're going to do as our ID dot f equals as dot factor ID. So like I said, we'll explain later why we need a factor ID. It's for the ezANOVA package, for the ezANOVA function that we're running, we need to factor all of our variables. We're also going to factor con.f equals factor cond. Let me just go ahead and take a look at this. Okay. Levels equals C0, 1. Labels equals C quote control and comma treatment. Okay, we do comma. Actually, this comma is going to be outside here. And then we're also going to do length dot f, which equals factor length comma levels equals C 2, 3, 4 comma labels equals C. We'll do 2 sil comma 3 sil comma 4 sil. I think I got that correct. Okay, so we should not run into any problems hopefully in running that. But as you can see, we just use the as.factor to factor ID number. We're factoring our con variable into a new variable called con.f and length into length.f. And we go ahead and run that. Yep, and we have 7 variables. And just confirm we did it correctly. It looks like it did. So we have our id.f, which is now a factor version of id. Okay, let's see what we got next. Okay, so the next thing I wanted to do was explain what this ezANOVA function was. So in ezANOVA is the function that we're going to be. This runs a repeated measure as ANOVA for us. So what it takes is it takes a data frame argument in which we just indicate the data frame. We do dv equals the outcome variable. We do WID equals the variable that identifies the participants. So that's that ID variable, and it needs to be factored. Our within variable is the repeated measures, so our syllables, which is the repeated measured predictors, which is our within variables. Between equals between group predictors, which is our noise and unnoise, quiet and noisy condition. We want detailed equals true, just so we have more output, and type equals 3. All right, so go ahead and do that. So what we're asking with our first research question, we're going to separate this into 2 analyses. I want to do one where it was just a within subjects factor, and then we'll add in the between subjects factor. So our first one is saying, does length of time to read each word significantly differ by word syllable length? So we're going to completely ignore condition 1 for now, our condition for analysis 1. So what we're going to do is we're going to just plug it into that ezANOVA. So we're going to indicate the data set, the dependent variable, the within ID, the within factor. We're not going to do a between factor, and we're going to do detail equals true and type equals 3. So let's go ahead and get started on that. So let's do hashtag repeated measures ANOVA. Actually, we're going to do that as 2 hashtags. I'm going to do hashtag analysis 1. So go ahead and insert a new R chunk. I'm going to get back up to my notes here. Okay, so we're going to use the function ezANOVA, NOVA, in parentheses. I like to go ahead and just go down a little bit, so I think it's easier if I read it like this. Data equals syll, comma. Our dependent variable equals time, comma. Our WID, which stands for our ID variable, equals id.f, comma. Our within equals length.f, comma. Detailed equals true, comma. Type equals 3, which indicates that it's a type 3 ANOVA that we'll be running. Okay, so we go ahead and run all that. We should get some output. And voila, you get 4 different windows in here. Okay, so I told you what it all is. And you get 4 different windows in here. So first window is just your R console. It's just saying if there's going to be any errors, it'll be reported there. Then you have the ANOVA table. Then we have the sphericity test, which is that concept I talked to you about earlier, in which we're saying is the differences between our treatments the same or different. And then the greenhouse Geiser-Hunfeld corrections. So the first thing we always do is we check the sphericity and see if it was violated. A significant test in sphericity indicates that it's that sphericity was violated. So a significant value means sphericity was violated. This determines which window we look at next. If sphericity was violated, we'll go ahead and look at the greenhouse Geiser correction. If it was not violated, which means the P was greater than 0.05, we use the standard ANOVA table. And that's where that sphericity comes in and is so important here. So with our model, I can go ahead and show you an R2. So we go to the third window, and then we ask ourselves, was sphericity violated here? In which we say, we look at our P value here, and we say, is our P value less than 0.05? And essentially we're saying, no, it wasn't violated. So we have the choice of going to window 4 or window 2. Because sphericity wasn't violated, we go to window 2. Okay? And so I tell you that in here, and I say, was it violated? No, it wasn't. So we go to window 2 of our ANOVA table. So what we get here is we get a lot of information. We get the intercept with saying that when length.f is at 0, is there a significant value? And we say, yep, it's significant. Then we have the length.f, and we're saying, are the lengths significantly different from each other? And we're saying, yes. This is 3.84 to the -4, so it's 0.0003, essentially. So less than 0.05. So we're saying, is this significant? Does syllable length differ in the amount of time it says to say the word? And the answer is, yes, it does differ. So what we can do from there is we can go ahead and visualize the effect. So what we're going to do is going to go ahead and visualize the effect. Let me just go to my PowerPoint to make sure there's nothing else. Yes, and we're going to use this group. We're going to be using the group by and summarize and then plotting it with ggplot. So to do this, so let's go ahead and do hashtag visualize the effect. Insert in our chunk. What we're going to do, we're going to name a new object called syll_sum, in which we're going to do group by, in which we're going to group our syllable data set, comma, we're going to group it by length.f. Then do syll_sum again, and then we're going to summarize it by syll_sum, so it's our data set that we're summarizing, time equals mean time, na.rm equals true. There's no missing data, but I like to do that anyways. And we're going to do syll_sum, and then we're going to do ungroup syll_sum. So when we run that, so what's going on here is we're grouping it by length.f, and we're getting the summary of that variable, of the time variable by length.f, and then we're simply ungrouping it just so we don't run into any errors later. So I'll go ahead and run that and show you what happens. So we have this new object called syll_sum, which just got time differentiated between 2-syllable, 3-syllable, and 4-syllable. Okay, then we're going to use our ggplot. So we'll do ggplot. We indicate the syll_sum data set, which is just this one that's the summarized data set. Syll_sum, then we set our aesthetic, and we say x equals length.f, comma, y equals time, comma, fill equals length.f. And we're going to be using a new geom layer that I don't think we've used at all in this class. We're going to be using geom call. So we're going to be creating a column graph for this. Width equals 0.5. That's just to make them look a little bit nicer if the width equals 0.5. And then I'm also going to add in a theme. I'm going to do theme BW because I just think it looks really nice with the column charts that have a black and white theme. Then let's go ahead and set labs. So we're going to say title equals quotation does length of time to read each word significantly differ by syllable length, question mark, comma, fill equals word length. That's just going to set our legend, so it says word length instead of length.f, and x equals word length. Okay, if all that runs correctly, then we should have a nice looking graph. Oh no, oh, I misspelled fill. Okay, here we go. So if you misspelled fill, it gives you some gray charts apparently. There we go. That's a much nicer looking chart there. So as we can see, it seems like it doesn't look like much, but keep in mind this is measured in milliseconds, so the difference between 2, 3, and 4 can be a lot. So it's saying that there's a significant difference somewhere in this, in here, saying that there's a difference between 2-syllable, 3-syllable, or 4-syllable words and the amount of time it takes to say it, essentially. Okay, so we created some visualizations just to show you what's going on. And now, let's see what we got next. Now we're going to go on to analysis number 2. Now we're going to run a mixed effect ANOVA to evaluate the effects of both number of syllables and noise condition on time. So we're adding in that between factors. So we say, does length of time to read each word significantly differ by syllable length and by condition? So to do that, we're actually going to be filling in the exact same ezANOVA that we did before, but we're going to be adding in this between argument, and we're going to add in between equals condition, and saying that we want to see if there's a difference between participants and condition as well. So let's go ahead and do that. So we'll do hashtag analysis 2, do insert, or we'll do, actually, see what I did there. We'll do hashtag mixed design. So hashtag mixed design. insert a new R chunk. So again, this is going to be ezANOVA, parentheses, we set our data set, so data equals syll, comma, dv is still time. Everything's going to be the same except for one thing. WID equals id.f, comma, within equals length dot f, so that's our within subjects variable. Between, which is now our between subjects variable, equals cond dot f, comma, detailed equals true, comma, type equals 3 to indicate that we want to run a type 3 ANOVA. So we go ahead and run that. Okay, so we came up with these three windows again, and we're going to be checking to say, was our sphericity violated at all? So we look at this, and we say, is p less than 0.05 on either of these? And we say, nope, p is more than 0.05. So it's saying sphericity was not violated. So because of that, we go to window 2 instead of window 4. So sphericity was not violated, so we go to window 4 to look at our results. And we say, okay, cond.f, does syllable length vary by condition? Okay, and we say, nope, it's not varying by condition. So it doesn't matter whether you're in the noisy or loud or quiet condition. The variable doesn't seem to, the amount of time it says, the amount of time it takes to say each syllable doesn't matter. Sorry about that. Then length.off, we search and say, hey, is this significantly different? Saying, yeah, in here, there's a difference between saying a 2-syllable word, a 3-syllable word, and a 4-syllable word. Then the last one, we're saying, is there a interaction between condition and length? And we say, yeah, there is an interaction, saying that the amount of times it takes to say a syllable word matters based on what condition you're in as well. So there's a difference. So what we're going to do is I'm actually going to go ahead and map out and visualize that interaction effect as well. So what we do is we're going to go ahead and do hashtag visualize the interaction effect. I'm going to insert a new R chunk. So this is going to be similar to how we were doing the column charts earlier with the summarizing it all. So we're going to rewrite over our syll sum data set that we have in here. So we're going to rewrite over this. Okay, syll sum. We're going to do group underscore by syll, comma. We're going to group by con.f and then length.f. And remember, order matters, so make sure you do it by con.f first. And then we're going to do syll sum, use an assignment operator, use summarize syll sum, comma, time equals mean time na.rm equals true. And then we're going to do syll underscore sum, and then we're going to ungroup syll sum. There we go. So when we run that, we're just going to rewrite over our syll sum data set. So now we have 6 observations of 3 variables. As you can see, it's incorporated the condition.f in there as well now. And we're looking at the differences in times between the length of the syllables. Then we're going to go ahead and try and create a interaction graph, which is going to be really great. So we're going to do ggplot syll sum, comma, aesthetic x equals length dot f, comma, y equals time, comma, color, not fill, color equals cond dot f. We do plus, we're going to do a geom line. And this is a weird thing that you have to do with geom line sometimes, is that you have to use this aesthetic within it and say group equals cond dot f. I know that we did the color up here with it, but it just, for some reason, geom line is like that. I don't really have a good answer for you as to why it's that way. Do theme BW, because I kind of like that theme, plus, and then we're going to do some labs. So title equals quotations, does length to say syllable vary by condition? Question mark, comma, color equals quote condition. That's just setting up our legend so that it will give us a condition instead of con.f, comma, x equals quote length. Okay, so if we run that, hopefully it should run appropriately. There we go. And we got our interaction graph. So as we can see, going from 2-syllable to 3-syllable to 4-syllable is different in the treatment condition, which is the noisy condition, as compared to the quiet condition, where it seems like it takes a lot longer to say 4-syllable words within the treatment condition as compared to the noisy condition. There's a sharp increase in the number of syllables and the amount of time that it takes to say each word, specifically within the treatment condition, whereas in the noise condition, in fact, it even says, hey, when you're in a quiet condition, it takes less time to say 4-syllable words. Okay, so that's pretty much all that I have for you for repeated measures. And I tell you kind of what the SSD is. It's an error term and the amount of unexplained variance across the conditions of the within subjects factor. And then we go ahead and we plot the graph. So I also want to say, so what should we do if sphericity assumptions is violated? So we didn't violate any of these assumptions, but what I want to do is I'm going to go ahead and show you what would happen if we did actually violate an assumption. So let's go back up. So this is our window 3. So let's say, for instance, that this was p less than 0.05, and we did violate our sphericity assumption. So instead of going to window 2, you'd go to window 4 and simply say, okay, does length.f differ? You'd say, yes, it does differ. And does condition by length.f differ? You say, yes, it does differ. So that's really the main difference that you would say, is that you just go to this other window and say, does it differ by this and whether than this? And that's pretty much it. Okay, so I have an assignment for you up on Module 6 Lab that you can go ahead and get started on. All right, well, thank you so much and look forward to seeing your assignments.